For this video, we're going to solve 2007 AP Calculus Form A FRQ Question 6. So it says, let f be the function defined by f of x equals k root x minus ln of x for x is greater than 0, where k is a positive constant. Okay, so k is positive. Find f prime of x and f double prime of x. So part A. If we want to find f prime of x, we're just going to take the derivative. So derivative of this would be k over 2 root x times 1, because the derivative of x is 1, minus 1 over x. Then f double prime of x is going to equal, okay, this is going to be a little bit trickier, or we could say k over 2x to the negative 1/2 minus 1 over x. So now the derivative of this is going to be negative k over 4 x to the 3/2, yeah, in the denominator. So now 3, 2, and the derivative of 1 over x is x to the negative 2. Okay, part B. So for what values of k does f have a critical point at x equals 1? For this value of k, determine whether f is a relative min, relative max, or neither at x equals 1. So if you want to find relative min or max, it's where derivative equals 0. Luckily, they gave us f prime of 1 is going to equal k over 2 root of 1 minus 1. And this thing has to equal 0 if it's going to be a min or a max. So now we're going to get k over 2 minus 1 equals 0. So k over 2 equals 1. K has to equal 2. Now, if we know this, we're going to go back in here and we're going to use the second derivative test. So now we're going to have negative k over 4 root of 1 plus 1 over 1. And we are basically seeing if it's positive or negative. Plug in whatever the value is for k. So now we got 2, right? So if we plug in 2, we're going to get negative 2 over 4 plus 1. And now we're going to get positive, right? So if this thing is positive, that means it's going to be a min because it's concave up. So it has to be a min. So f has a relative min at x equals 1 because f double prime of x was greater than 0. Okay, part C. For a certain value of constant k, the graph of f has a point of inflection on the x-axis. Find this value of k. So it's where the second derivative equals 0, right? So let me put it over here. So we have negative k over 4 x to the 3/2 plus 1 over x squared has to equal 0, right? So now we have to get k by itself. So we're going to get k 4 root x to the 3rd equals negative 1 over x squared. So now we're going to cross multiply. We're going to get k x squared equals negative 4 cubic root of x squared. So now we're going to get k equals negative 4 x to the 3rd over x squared. And this could be reduced slightly. So we're going to get k equals, and let me put a line over here so I can see what I'm doing. K equals negative 4, that's x to the 3/2. That's x, so 3/2, 4/2. I could say that was negative k. negative, negative, negative. Can't lose it. So k is gonna equal 4 over root x. Okay, so now let me move this over a little bit so I could do the rest of my work. Okay, so if I go back to the position function and I say 0 equals k root x minus ln of x, I can now say k root x equals ln of x, k equals ln of x over root x. And now I know both of these have to equal one another. So now I have 4 root x equals ln of x root x. So now I'm going to get 4 root x equals root x ln of x. So now I'm going to get 4 equals ln of x. Move this over. So now I'm going to have to unln it. So now I'm going to get e to the 4th equals x. Yeah, that's e to the 4th. So now k is going to equal 4 over root of e to the 4th, which is going to equal 4 over e squared. So this is going to have to be where the point of inflection is, and I don't really want to test to the left and to the right to make sure it is true or not. Okay, thank you, and I hope this video helped.